This video reviews the law of conservation of mass and how to balance equations. The law of conservation of mass tells us that the mass of the reactants is equal to the mass of the products in a chemical reaction. So since mass is made of matter, that means matter cannot be created or destroyed. And this law should sound pretty similar to the law of conservation of energy, when we said that energy cannot be created or destroyed. So for this law of conservation of mass, that tells us that we are not allowed to delete atoms, like make them disappear, and we're not allowed to add them randomly. We can't just make them appear. They have to come from somewhere and they have to go someplace. All right, so what we're going to be doing is balancing chemical equations so that they obey this law of conservation of mass. And that means we'll want to make them so that they have the same number of atoms of each element on both sides of the equation. So for the typical equation, you'll have the reactants on the left, on this side, and then you'll have an arrow, and you'll have your products on the right. And for every single element in the reaction, we want to have the same number of atoms on the reactant side as on the product side. So let's do a couple examples. We did these in class, so the first three. So we did one chemical reaction where we broke apart water. This was electrolysis. We had a beaker of water and we ran an electric current through it, and we broke up the water into two different substances, two new substances. So that's how we know it's a chemical reaction. So this was a decomposition reaction. We started with one substance and we broke it apart into more than one, two in this case. So just take a look at the formulas really quick. These subscripts tell us how many atoms of each element are in this compound. So when I see this 2 here, that tells me there are 2 hydrogens in water. And there's no subscript here, which means there's a 1, essentially. So there's 1 oxygen. That's why I wrote the letter O there. And here's my 1 oxygen in my molecule of water. Over here on my product side, I've got a subscript 2 because I've got 2 atoms of hydrogen in this molecule of hydrogen gas. And likewise, I've got a 2 with my oxygen because I've got 2 atoms of oxygen in my oxygen gas. So when we look at these substances, these are their formulas. We may not change them. You are not allowed to change these. These subscripts are set. If I were to, for example, decide to put a 2 in the subscript here for oxygen because I just feel like having another oxygen, well, this is no longer water. H2O2 is hydrogen peroxide. That is not something you want to drink. Very, very different substance. So changes the identity. So we have to leave the subscripts and the letters here in place. We cannot change them. Okay, so we'll keep that in mind as we try to balance this reaction. So we're going to use our handy little grid here and consider what elements do we have in this reaction that we're going to have to balance. So I would always, when we're balancing equations, save oxygen for last because it can get kind of complicated. And so in this case, we're going to start with hydrogen. So I'll put the hydrogen at the top of my grid here. All right, so now I want to figure out how many atoms of these elements do I have in my reactant side and in my product side. So over here are my reactants, and I'm going to count up the number of hydrogens I have. So we've got pictures, we can kind of look at it, and I can see there's 2 hydrogens here. Also, we can just look at the formula and see that there's a subscript 2 after the H, so I know there's 2 hydrogens. So I'll put a 2 in this box. Now for the oxygen, I can look at my picture, yeah, I've got one right here, or I could look at my formula, and I know that there's 1 oxygen in this molecule of water, so I'll put a 1 there. All right, now over here on the product side, how many hydrogens do I have? I see 2. And oxygens, same thing, I see 2. So now we're gonna say, all right, is this balanced? And we'll look at each of our atoms and make sure that they have the same numbers on both sides of the equation, both the reactants and the products. So I see here, yep, I've got 2. I started with 2 hydrogens and I ended with 2 hydrogens. I used these 2 hydrogens to make my product, and so these 2 hydrogens came from this water. They're these 2 hydrogens. When I'm done with this reaction, this water molecule no longer exists. These hydrogens have turned into this hydrogen gas. So my hydrogen here appears to be balanced. So let's put a check box in there, check mark in the box, and go to the next line in my grid. So the next one's oxygen. Is this balanced? No, it is not. I started with 1 oxygen and I ended with 2. That breaks the law of conservation of mass. You can't just pull atoms out of nowhere. So we need to figure out how we can balance this. Could we just take away the 2 down here, and so we would have 1 atom of oxygen? No. 1 atom of oxygen is not stable. It doesn't have enough valence electrons, and it would want to bind to something. And in this case, it finds another oxygen to bind to, so it has to be O2. So we can't do anything about that. So instead, we're going to come over here to the reactants and just, add more reactants. We can start with more, so that way we end with the right amount. So what we'll do is we will play with our subscripts. Coefficients. Oh my gosh. Coefficients, the numbers that go in front. These are the subscripts. Sorry about that. So our coefficients are the numbers that go in front of our substances. So if we want to have another atom of oxygen, what we can do is just say that we have another molecule of water. So we'll do that. So now you can see we've got 2 oxygens here, and that's because we have 2 molecules of water. And that 2 as a coefficient tells me that I have 2 of these groups of water. So now we need to update our atom totals here in our reactants. So they're both wrong now. Notice I've got more hydrogen and I've got more oxygen. So I need to fix both of these. So I'll just put a line through them. I wouldn't erase what you wrote, kind of just put a cross through it, so that way you can see your work in case you need to go back because you made a mistake. So I put a line through them, and let's update our totals. We've got now 4 hydrogens. You can count them, 1, 2, 3, 4. Or we could see that we've got 2 groups, and each of those groups contain 2 hydrogens. So I multiply 2 times 2, and that's 4. And my oxygens, I can count them, 1, 2. Or I could look at my formula and imagine there's a 1 here. And so I've got 2 groups, and each of those groups contains 1 oxygen. So 2 times 1 would be 2. All right, so now that we've messed with the coefficient, let's go back and see how we are doing with the balancing. So we'll start at the top. The first row, is my first row balanced? No, it appears I messed it up. So we're going to cross off that check mark. It is no longer balanced. But my oxygen here appears to be balanced. So that's good. At least we haven't made it worse. I've still got one of these things balanced, and that happens a lot. Sometimes in the process of balancing one thing, we end up messing up something earlier. But that's okay. We did the easy ones first, so we can fix this one very easily. Okay, so let's go back up to our hydrogen and fix the hydrogen. So right now, it reads that I started with 4 atoms of hydrogen, and I ended with 2. And that appears, again, like I broke the law of conservation of mass. 2 of my hydrogen atoms just up and disappeared, and that's not okay. So we need to reflect them somewhere in our products. And we know that our products are only hydrogen gas and oxygen gas. So what we can do is just say, well, we must have ended up with more hydrogen gas. And if we're looking for 2, let me rephrase that. We want to end with 4 atoms, and so if we imagine putting a 2 as a coefficient here, that would be like having another molecule of this hydrogen gas. And now when we update our atom count, we see that we have 4 atoms. 2 groups of these molecules which have 2 hydrogens each. So 2 times 2 gives me 4. So am I balanced yet? Yeah, we have 4 atoms of hydrogen in the reactants and now 4 of them in the products. So we're balanced. And our oxygen is still fine. Changing my coefficient here didn't affect the oxygen over here because the coefficient is only tied to this substance, this hydrogen gas. It has nothing to do with the oxygen gas over here. So my oxygen's still balanced, and this equation is done. We have fixed it so that it reflects reality and it obeys the law of conservation of mass. Okay, next one. So we'll do these a little faster now that I don't have to explain all the details again. So we start with magnesium, which is a metal, and oxygen gas, and we're going to make magnesium oxide. This would be an ionic compound. Previously, the last one was a covalent molecule, right? Because these are both made of nonmetals and therefore a covalent bond where they're sharing electrons. Here we've got an ionic bond, a metal and a nonmetal. So we're making magnesium oxide, an ionic compound. All right, so let's balance it. We've got oxygen and magnesium here. Oxygen being harder, we'll save it to do second and do magnesium first. I've got 1 atom of magnesium in my reactants, and I've got 2 here of oxygen in my reactants. For the product side, I've got 1 magnesium and 1 oxygen. So we can see that the magnesium is balanced, that's fine, but when we go to oxygen again, it's not quite balanced. It looks like I made an atom disappear, which we can't do. So let's balance this by changing the coefficients. So we need another atom of oxygen over here somehow. So we can't just tack on oxygen, we can't change the subscript, because this reaction only produced magnesium oxide, and the formula for magnesium oxide is MgO. So all we can do is just say, well, we must have gotten more magnesium oxide. So we'll put a coefficient in, coefficient 2. And that means we now have 2 atoms of magnesium and 2 of oxygen. So we'll check, are we balanced yet? Well, our magnesium, we just messed up, so that's not balanced anymore. But our oxygen is, kind of like last time. So we can go back, though, and fix our magnesium. It looks like we're going to have to fix something in our reactants so that we start with more magnesium so that we can end with the right amount. So we will put a coefficient in front of the magnesium. Kind of like I knew I needed magnesium, so I found which of my substances contain the magnesium, this one here. So that means I've got 2 atoms of magnesium, and it looks like I am balanced. I now have 2 in my reactants and 2 in my products. So narrating this, when I made my 2 compounds of magnesium oxide, I got the 2 magnesium atoms from these 2 here, and I got the 2 oxygen atoms from these 2 here. When this reaction is over, if I made exactly 2 ionic compounds of magnesium oxide, then these would be gone. They are now part of the magnesium oxide. We had 2 substances reacting to make a completely new substance. Why it's a chemical reaction. And this is a synthesis reaction, by the way. We see we had 2 substances come together into 1. All right, let's do our 3rd example here. All right, here we've got, this is methane reacting with oxygen, and this is going to be a combustion reaction. So our products, or let me back up, our reactants will always include oxygen in a combustion reaction. And in our class in integrated science, we're always going to be doing combustion reactions with hydrocarbons here. So our products will always be carbon dioxide and water. So we'll always see oxygen in the reactants and carbon dioxide and water in the products. All right, let's balance this. Slightly harder because now we have 3 atoms. We've got carbon, hydrogen, and oxygen. Save oxygen for last, hydrogen for second to last. So let's do the easy one, carbon first. All right, so when we count up our atoms, we've got 1 carbon. You can see it in the picture, and we can count it here. And we've got 4 hydrogens. Here's my subscript 4, so that tells me I have 4 hydrogens, and you can see them in the picture here. And I've got 2 oxygens. And over on my product side, I've got 1 carbon, there it is, and I've got 2 hydrogens. And here's a kind of tricky part. I've got 3 oxygens. So here's 1, here's 2, and here's the 3rd. Don't forget, oxygen is in both of these. That's why this one's kind of hard to balance, because it's in both of our products, and why we'll save it for last. Okay, so let's start with carbon. Is my carbon balanced? Yeah, so that's great. Let's move on to hydrogen. Looks like I start with more than I end with. I start with 4 and I end with 2 here. So that's no good. So what we're going to need to do is change our products and make them more. We always go up, we never go down. We can't just take away this 4. That doesn't work. And there's only 1 of them. We can't have like half a methane. So instead we're going to change our water here because that's our product that contains the hydrogen. So we have 2 atoms of hydrogen and we want 4. So the logical way to do that is instead of having 1 water molecule, we'll just have 2 of them, like that. So when we update our totals, we'll have to update our amount of hydrogen and our amount of oxygen, because look, we just added another atom of oxygen as well. Okay, so we total up 4 hydrogens now, and 4 oxygens. 1, 2, 3, and 4. Okay, so we'll check, see how well we're balancing. Our carbon, still balanced, so that's fine. Now we'll go to the next line. Hydrogen, is that balanced? Yep, we're good. So it looks like oxygen, not balanced yet, so we gotta go fix this one. and we're going to need to change something on our reactant side. We can't bring this down, so we have to bring this one up. So what we can do if we want 4 atoms of oxygen is just say that we must have started with 2 groups of this O2. So see, now I have 4 atoms of oxygen. 1, 2, 3, and 4. And now we'll do our check again. Are we balanced? Carbon, still balanced, yep. Hydrogen, still balanced, that's okay. And now my oxygen is balanced. So I'm done. All right, let's do one more, even more complicated example. We're going to do another combustion reaction, but this is a much larger molecule here. C6H12O2. And since it's combustion, it has to be reacting with oxygen. And our products, what are the products going to be of every combustion reaction? They're going to be carbon dioxide and water, like always in this class. So let's balance this. We've still got the same 3 elements as our last combustion reaction: oxygen, hydrogen, and carbon. And so let's count up our atoms and then balance. So our carbons, looks like we've got 6. Here they are in our picture, they're the black ones. And hydrogens, we've got 12. You can count them up here, they're the white elements. And then oxygens, we've just got, oh, hey, that's not right. Okay. Bear with me. I updated this from the last slide. Oh, I know, I'm giving it away now. Oh no. Oh, I did have 4. Oh, I just made the mistake that all of you guys make. Can you believe it? Okay, let's go back. Okay, pretend you didn't see any of that. Pay no attention to the man behind the curtain. All right, so here's what I saw that for, and I was like, oh my gosh, wait, there's only 2 there. And you know what I did? I forgot about these 2. Happens to the best of us. So I know that I have 4 atoms of oxygen because I've got 2 here and then another 2 here to start. Okay, now my product side. I've got 1 carbon. Here's my 1 carbon. And my hydrogens, I've got 2. And my oxygens, I've got 1, 2, and 3. Okay, so here I see I've got a problem right away. My carbons aren't balanced. So let's start with those guys. I've got, let's see, 6 on this side and only 1 in my products. So I know that I'm going to need more of my carbon dioxide produced. That's my product that has the carbon. So right now if I have 1 atom and I need 6, so I'm clearly just going to need 6 carbon dioxides. So I'll change my coefficient and then I'll update my atom totals. And I have to update for both carbon and oxygen because that's part of carbon dioxide. So here's my updated totals. The 13 comes from the 12 that I have here, 2 on each of my 6 carbon dioxides, and then I've also got this oxygen from water. So just like I almost forgot to do here, don't forget your oxygen is really complicated. It's in so many substances. So don't forget to look at both of them. It's a really easy mistake to make. I just made it. Okay, so I updated my totals for carbon and oxygen, and let's check to see how we're doing with the balancing. Is my carbon balanced? Yes, I've got 6 atoms on each side, so that's cool. And here I have to stop. Hydrogen's not balanced yet, so let's go back and balance our hydrogen. All right, I start with 12 and I end with 2. Clearly I'm missing a whole bunch of atoms on my product side. So let's go back. We're missing 10 total. Start with 2 and I'm missing 10 of them. So if I were going to change one of these substances to increase my total atoms for hydrogen reflected in my equation, then I would need to change water here. That's the one that has hydrogen in it. So we'll say if we need 12 and there's 2 in each of these waters, then I know I'm going to need 6 of them. And it would look like this. So now when we do our counts, well, we need to update both our hydrogen and oxygen because we just changed them. So cross those off and let's update our hydrogen first. We now see that we've got 2, 4, 6, 8, 10, and 12. So that's good. And our oxygens, Now the numbers are getting kind of big. We've got 2, 4, 6, 8, 10, 12, and then 13, 14, 15, 16, 17, 18. So if you didn't have the pictures, which you're not always going to have, you've got to learn how to calculate it from the formulas. So remember, you multiply, kind of like you distribute in math. We've got 6 groups, and each of the groups has 2 oxygens, so I know I've got 12 here. And if I had pen and paper, I would probably scribble a little 12 down here on the bottom for myself. And then I've got 6 groups of water, and there's 1 oxygen in each of them. So I know I'm going to have 6 oxygens total. So I've got 6 oxygens here. So 12 and 6, that's how I got 18. Okay, so let's check to see if we're balanced. Is my carbon still balanced? Yep. Is my hydrogen balanced? Yep. I can check that off now. And oxygen, tragically, is not. So we need to fix our oxygen. And we need more reflected in our equation over here on the reactant side. So notice it's in both of them. Are we going to change the coefficient here? No, that would mess up all of our totals for carbon and hydrogen, and would have to start all over again. That would be a disaster. It's far easier to just increase our coefficient here in front of the oxygen gas, because that only has oxygen in it. So we're going to do that. So I've already got 2 of, I'm shooting for 18, right? So I've already got 2 of them here. So, and I'm leaving this one alone, which means somehow over with this substance, I want to get 16 oxygens. So 2 here, plus if I could get 16 here, that would get me to 18. So I need to think about what coefficient I would put here so that I could get 16 more, or 16 oxygens. So that would be 8. So here, now when we show it in pictures, you can see I've got 16 here, and then 17 and 18. So I reach my total of 18. And it looks like I am balanced. So my carbon's still okay, my hydrogen's still okay, and now my oxygen is balanced as well. All right, that is it.